looking at dimensions of physical quantities, it means the weight is related or associated to fundamental quantities. Okay, so the method of dimension can be used to show relationship between quantities when the mathematics is too complex. Before I give examples, okay, I'm going to show us a table of those fundamental quantities with their respective dimension. The first one we talk about fundamental quantities. We talk of length. The SI unit is meter. So anything measured in meter, centimeter, foot, feet, the dimension is what? L. That's dimension for length. The dimension for mass is capital M. The SI unit is what? Kilogram, which is what? Kg. But what we need in this aspect is just the dimension. The time. The dimension for time is just the first letter. Okay, that's capital T. It's measured in seconds, but dimension is what? Capital T. For electric current, we know the unit of current is ampere. That's A. So we can use I or what? Or A for the dimension. So all these are what? Are correct. So for current, it could be this or it could be this. So these are the major things we're going to be using. We're going to be using mostly those three fundamental units. Examples of dimension. The first one, I'm going to start with the speed, which is a distance over time. And don't forget, distance is measured in meter and time is measured in seconds. But dimension for meter is L. Dimension for time is capital T. So this is equal to what? L T, which is the same thing as what? L T minus 1. If you remove this part, you're going to have this format. That's dimension for speed. Speed and velocity. Speed and velocity, they have the same dimension. Okay, let's look at the acceleration. We know acceleration is a change in velocity over time, so which is equal to meter per second squared. Okay, and that will be equal to meter is what? L per T squared. If you want to remove this per, that will be L T minus 2. So that's dimension for acceleration. We can also get dimension for density, which is mass over volume. Your mass is capital M for dimension. The volume is what? L. That's meter cube. Okay, and meter is what? L cube, and that will be capital M L minus 3. If you remove this part, that's the dimension for density. We can get the dimension for pressure, which is a Pascal. Pressure is a force over area. It's force over area. But before we go to pressure, can we quickly go to force? Let's get the force first. Force is mass times acceleration, which is capital M for dimension for mass. And acceleration is what? Acceleration is meter per second squared. Meter L per second squared. That's the acceleration, which is L T minus 2. Remove this part. So you have dimension for force. So which will be equal to M L T minus 2. And then the area is meter square. That's L squared. Then you can bring in mathematics here. Apply your indices. This is power 1. Okay, and that will be M. So 1 minus 2. That's the L minus 1. And then T minus 2. So that's the dimension for pressure. Okay. Can we also look at the sixth one? Let's look at the dimension for work. Actually, work and energy, we have the same dimension. Okay, because they both measure in joules. Okay, so work is force times distance, and fourth dimension, we just finished that. That's M L T minus 2 times distance is measured in meter, but dimension for meter is L. So that will be M L square T minus 2. So that's the dimension for what? For work or energy. Can you get dimension for power? Power is energy over time. Don't forget, energy and work, they are the same thing. So that will be equal to this one, and time is what? Seconds. Can you combine them together? Apply your indices. that will be equal to m L2 t minus 3. This is power 1. By the time it goes up, you have c minus 2 minus 1. So that's the dimension for power. Let's see one or two more. Electric potential, which is voltage. Electric potential, which is voltage. And that's equal to power, power over current. So that's the formula for electric potential, is power over current. And we've gotten power here. So that will be equal to ml square t to power minus 3. The current is what? You can use this one. You can also use what? If you like, you can also use capital A. The two are correct. Okay? So if you bring this one up, so you're going to have ml square t minus 3, then the I. Okay? Or you call it, if you bring the I up, that'll be minus 1. That'll be I to power minus 1. Okay? Or A. So you can write I, you can write A to power minus 1. So these are a list of few of the dimension of physical quantities. We're still going to look at practical questions more on these aspects. Okay, quickly smash the watermarks on the video and subscribe to the channel. Click on like button and begin to share the links of this video on all your social media platforms. Okay, thank you for doing that.